So with electric cars everywhere, you might be thinking, why are we even talking about innovations for the good old gas engine? I mean, isn't that yesterday's news? Well, it turns out the final chapter for the internal combustion engine, it hasn't been written just yet, not by a long shot. And, that really gets to the heart of it. I love this comment from a Reddit user, Rad Philosopher, who said, it's amazing to see how after 100 years, we are still finding ways to squeeze out more power and efficiency out of the ICE. And they're so right. There's this incredible passion and some seriously clever engineering still happening. The story of the gas engine, it's far from over. It's just evolving.
All right, so let's jump right into that evolution. For more than 100 years, the goal has basically been the same: make the internal combustion engine, the ICE, better in every single way. And one of the biggest leaps forward in that whole quest? The turbocharger. This thing was a game changer. Suddenly, engineers could build these smaller, lighter engines that could totally punch above their weight class, giving you the power of a big V8 from a little four-cylinder, all while sipping fuel. It's an absolutely brilliant piece of tech, but it's always had this one big, frustrating problem.
Okay, let's get into it. Every great hero has a weakness, right? Their Achilles heel. And for the turbocharger, it's a flaw that drivers have been, complaining about for decades. So what does a turbo even do? Well, at its core, it's basically a super clever recycling system. Think about it. Your engine creates all this hot, high-pressure exhaust gas. Normally, that just gets shot out the tailpipe. Total waste of energy. A turbocharger grabs that waste energy and puts it back to work.
And this diagram shows exactly how it happens. See that red arrow? That's the hot exhaust gas coming from the engine. It flows in and spins this little pinwheel, which is called a turbine. Now that turbine is connected by a shaft to another pinwheel on the other side, the compressor. As it spins, the compressor sucks in fresh air, that's the blue arrow, and crams it into the engine. And the formula is simple. More air plus more fuel equals more power. Boom. So you can see the trade-offs here pretty clearly. Compared to a normal, what we call a naturally aspirated engine, one that just breathes air on its own, a turbo gives you way more power, more torque, and better fuel economy, all from a smaller engine. The pros are huge. But look at that top con, the big one, turbo lag. It's that awful, frustrating hesitation you feel when you hit the gas. So what exactly is turbo lag? Oh, you know the feeling. You put your foot down on the accelerator, you're ready to go, and for that split second, nothing. Just a pause. Then whoosh, the power kicks in. That delay happens because when your engine is just idling or at low speed, there isn't enough exhaust gas puffing out to get that turbine spinning really fast. It's kind of like having to take a deep breath before you can blow out a birthday candle. There's always that little delay. But what if you could just get rid of that delay entirely? Well, that's where our hero comes into the story, a solution that's as brilliant as it is simple. So let's just think about this for a second. The whole problem, the lag, it exists because we're waiting around for the exhaust gas to do its thing. So what if you didn't have to wait? What if you could just spin that thing up to speed instantly? And here is the beautifully simple solution. What engineers did was place a tiny but super high-speed electric motor right on the shaft between the compressor and the turbine. I mean, look at it. It seems like such a small change, but in the real world, this one little addition changes absolutely everything. Okay, so let's see how this all works together. You're at a stoplight, engine's at low speed, the light turns green, you hit the gas. Instantly, before there's even enough exhaust pressure, that little electric motor, you see it labeled EM here, it kicks in and spins the compressor up to speed. Just like that. You get boost right away. Then, as your engine revs up and the exhaust starts flowing, the exhaust takes over and spins the turbine like normal. The electric motor has already done its job and it just hands off the work. It's seamless. All right, so that's the theory. And yeah, it sounds fantastic, right? But does it actually work in the real world? Let's look at some data and see what kind of a difference this thing really makes. To find out, we're diving into a research paper from the engineers at Palestine Polytechnic University. They built these super detailed computer simulations to test this out. So on the left, you've got your standard old-school turbo engine, and on the right, you've got the exact same engine, but with that little electric motor added in. And wow, the results are, well, they're not even close. This chart basically shows how long it takes for the boost to kick in. Now look at the standard turbo. It takes a full 2 seconds before you feel that power. That's your turbo lag right there. Now, look at the electric turbo. The response time is so fast it barely even shows up on the chart. It is, for all intents and purposes, instantaneous. The difference is night and day.
So the takeaway here is pretty simple. It works. The data doesn't lie. That annoying delay, that hesitation that's been the hallmark of turbo engines for decades, poof, it's just gone. But wait, it gets even better. The benefits don't stop with just eliminating lag. See, by getting that air into the engine exactly when you need it, the whole combustion process gets way more efficient. So not only are you getting more power from every single drop of fuel, but as a fantastic bonus, you're also creating fewer harmful emissions. It's a total win-win. Okay, so what does all this mean for the cars we can actually go out and drive? Because this isn't just some science project or a cool theory. This tech is already hitting the pavement. In fact, major high-performance brands like Mercedes-AMG are already putting these electric turbochargers in their cars. They're using it to get that instant, snappy throttle response, that feeling you usually only get from an electric car, but they're combining it with the raw power and, let's face it, the awesome sound of a performance gas engine. So let's just recap the whole thing. The benefits here are massive. You get rid of that annoying turbo lag for instant throttle response. You get more power and more torque. You improve your fuel efficiency. And on top of all that, you reduce harmful emissions. It basically takes the single biggest weakness of the turbocharger, throws it out the window, and makes all of its strengths even stronger.
And all of this leaves us with a really fascinating question, doesn't it? Is this electric turbo the final, brilliant chapter for the gas engine? The tech that perfects it just as its era might be winding down? Or is it something else? Is it the start of a whole new story for hybrid performance, the key that unlocks a new kind of car that perfectly blends electric response with gasoline power? I guess only time will tell.